Hello and welcome to this Crystallized live stream. This stream is in the category we call internet craftsmanship, which is focusing on what we can do to level up our skills when doing or building our part of the internet, so to speak. My name is Bård, and today I have with me Basil, which is lead frontend here at Crystallize.
Yeah, hi everyone. I'm really happy to join board today for this live stream because the topic is really exciting and I think it's going to be really cool.
It is a cool topic, and I think it's a topic that is getting more and more interest. At least that's what we see. And it's basically about how can you use 3D models to enrich your e-commerce experience. So to be able to both see a product and maybe configure it and see the changes in 3D, like we do here with, this is actually one of our open source boilerplates, but basically giving me the feel to, inspect the product, but also maybe see it in context in terms of dimensions and such. It's not necessarily a perfect representation of how the product actually will look, but it's a good guide to very clearly show, I would say, the customers how the product experience will be. So we'll definitely look into the details of that. For those that want to check out, we do have a boilerplate or an accelerator here on what I just showed. You find it on crystallize.com, product configurator boilerplate. And that is a good starting point to experiment yourself. As I mentioned, when you have 3D models, it might not be exactly the look and feel that you expect when you, let's say, like Swiffer, which I think is a really good example, because they show you the configuration of the product with the material, as we've shown before, and also the dimensions. So it kind of gives you the information you need in order to purchase. They also have module sofas that you can kind of build together and kind of get the full experience. But I also combine this, which I think is brilliant, with a lot of products or product photos in context. Of course, you want to have a sofa on your tennis court, and information about the actual materials, and also possibility to explore other variants of that product or that specific configuration, but maybe with different fabrics. And this is kind of where you get the combination of, I would say, the value of a 3D visualizer with also the possibility to just explore the fabric, for example. And here you see the fabric even on other products. So that, I think, is a brilliant combination of storytelling, inspiration, and also giving us the ability to, configure a product in 3D and get instant visualization of how this is going to look. And again, shout out to Martin and the team at Zeta in Sweden, which has built this for Swift, of course, on Crystallize. But yeah, that's it for an intro. Yeah.
Maybe one thing here, Board, that we can also mention when we talk about 3D models is that we can take even this experience even further if we use augmented reality, right? And exactly. In this case, with the furnitures, with the couches, it's like very nice to actually get to see the couch in your real environment, like in your own home, right? Where you can use augmented reality, put it the place where you're planning this thing to stay, right? And then you see how it fits with the rest of the room.
And this is
also a benefit that we get with the 3D models.
Definitely, and where you can place the sofa and kind of see the dimensions fitting. So that sounds terribly complicated to me. So if you start at the basis, so I have a product and I have a picture of the product or description of it. Where do we start?
Yeah, I think this is really good question actually, because quite often when you see something like this, you think it's very complex to build and make. And what we want to do here, really, we want to show that actually it's not that complicated to build something as we, for example, has, or like the product configurator. And the first thing that we need to do, right, like where we start here, we start from actually getting a 3D model, the model file, the file that contains the model. And for that, you have a few options here, right? You can either use an agency, third-party agency that can build the model for you. You can also hire a freelance 3D designer that can make the model for you. Or you can even make it on your own using, for example, Blender, which is a open source tool that you can just play a little bit more and also start with, to experiment at least, to get some idea of how we can change nodes, shapes, right, and materials.
But of course, if you're new to 3D modeling, get some help on that account. But it's not an impossible task, so to speak.
Yeah, definitely, and especially if you want to take it on a professional level, right? You better be more precise on how your item is going to look, your product. You don't want just to have rough edges. You want to get as close as possible.
Yeah.
This is definitely the starting point. What is good about that, right? So it sounds a bit complicated, but definitely just hiring somebody to do it for you, or agency, it doesn't matter. You are paying kind of the thing once to have the model, but once you have the model, we can manipulate it by code. And this is where actually the power of these 3D models comes, right? Because in the end, this is a code that we can manipulate easily, and we can achieve so much with it.
So I get somebody to create me a 3D model. If you're manufacturing products, you most likely already have it, right? So it's maybe more about setting the materials up correctly.
Yeah.
So what kind of software do I need then to get this 3D on my web shop?
Yeah. So here there are a few different options that you can go with, but today I would like actually to use the one that is most probably the simplest one. And I'm saying there are different options because you can go like really down to the bare metal when it comes to 3D models, and that requires a lot of knowledge and to have in order to make it work. But with the model viewer, this is an open source package by Google. You can, as it says here, the slogan, it allows you to easily display interactive 3D models on the web and AR. So this is the tool that we will be using today to render our 3D model. What is interesting about the model viewer is that the model viewer is a web component. And because it's a web component, that allows actually using it with any framework that you may want to think of, like React, Vue, Angular, name it. You just can grab the element and it's going to work because it's a web component. And that's actually that's a big advantage, right? You are not bound to any specific framework. You can even go with bare JavaScript, like no problem at all. Yeah. So what else? The model viewer, it's using two types of standardized file formats for 3D models. And those formats are GLTF, which stands for Graphics Library Transmission Format, or GLB, which is the binary version of it. So we need to have one of these, we need our model in one of these two formats, and then we can pass that to the model viewer to render it.
And these are formats that, Blender will just export to, or?
Yes, definitely. And this is quite standardized file format for 3D data. So when you ask somebody to prepare that for you, they won't be surprised at all, because this is very standard way of representing 3D data.
So am I getting this right? So Blender is open source, right? This is a pretty powerful 3D, I think it's both rendering and creation tool, right?
Yeah.
And you're saying that this is basically a web standard, a web component, but let's call that. It will run in almost any browser, I would say, and you can use any front-end framework because it's just standard, call it HTML, and you can manipulate it with standard vanilla JavaScript, right? So it seems pretty accessible already.
Yeah, it's not bound to anything. It's very open, and you can use it everywhere. And one additional advantage of the model viewer here that I'm going to mention also is that, as I said, things may get very complicated when it comes to 3D modeling, but the model viewer is kind of abstracting that for us, right? So what they're using under the hood, something that we are kind of not seeing as a simple user of this, they're using 3GS. 3GS is a library for 3D models, which utilizes the GPU for rendering. And that makes the performance superb, right? When you are moving and when you are playing with the model, everything just refreshes on the screen immediately, and then you get to see the kind of the model in a new position, like as it is, for example, over here. As you can see, I just rotate it, and then you can zoom in, zoom out. You can even see the reflection here in the helmet.
And this is a pretty high resolution model, I would say. I mean, talking about web standards, this is kind of different than back in the day with was it Java applets? It was called, which was let's say non-performant. So this is awesome.
Yeah.
So okay, you talk about you do the talk, but what if I want to build this, and if I'm a newbie like I am on building this, how would I start? What do I need to understand, and how can I build this?
Yeah. Okay, so let's take a look at some code, right, and see how things work under the hood. Because kind of explaining that it's easy, people may believe it, may not, but let's see it in action, right?
And I like when you say, okay, this is easy. Let's dive into some code. And I mean, disclaimer: this will get pretty nerdy.
Yeah, we will look at a lot of different things.
Yeah.
Cool. So what you see here on the screen, I have a simple React project that I boot up. Why it's React? Because we like React. It could be anything, as I said. So use whatever fits your preferences. And to start with the model viewer, here we have actually two options. Either we can import the model viewer from a CDN, where we can just fetch specific version that we want, and then the model viewer comes built kind of bundled with the 3GS dependency in it. Or we can install it as a package, like I did in this case over here. As you can see, here I have the dependency of the model viewer. I'll move. And then I have also 3GS. So once we add the model viewer to our project, the next step, in case you're using it as a package, we need to import the model viewer in our project. So I'll go here to main TSX, and as you can see here, I just import the model viewer from the package. So what we are doing here is that now when we render the model viewer web component, the library will take over the component and do its magic, right? That's everything what happens by just importing the model viewer. If it is done through the CDN, you don't need to do anything. You just add it as a script, and then everything just works. Cool. Okay, before kind of diving into the code, here I prepared two GLB files. You remember the graphic library binary file? Yeah, that's what we need for the model viewer. And in this case, I decided to use one of our characters that we use quite often on our website. It's a robot, right? A robot character that we can actually render as a 3D model, and then we'll kind of look at a few different things. So you see here under my public folder, I have these two GLB files, which we'll take a look later. And then over here, I have an empty page to start with, right? So the first thing actually is to test if we're looking at the right thing. So as you can see here, I just change this and it appears on the screen.
Magic.
Cool. That's definitely magic. Okay, the first thing we need to do when it comes to the model viewer, we need to add the model viewer web component. No surprise there. And then the model viewer takes a property which is called source. And the source is just the GLB file. So here I will say /robots.glb. I will save this. And when I go back, boom. This is like with a single line of code, we render a 3D model on the screen.
Okay, but that was simple. I mean,
yeah. I mean, now it's kind of doesn't feel like 3D, right? It's quite static. It's looking also the other way. I'm not sure what is so interesting over there, but let's try to maybe turn a bit the robot so it looks our way instead of over there. So there is a property which is called camera orbit on the model viewer, and here we can set what's the initial camera position in X, Y, and Z axis. So here I'll say let's rotate it 65 degrees in X axis, and then zeros for the rest. So when we go back, you see, boom, the robot is already looking our way. It's much better, right? So now it's kind of, we are the main people here, the focus.
Nice.
What else we can do? Maybe let's try to add a little bit shadow below the robot, so it actually feels like it's standing on a surface rather than floating on the page as it is right now. To do that, we have two properties here. That is shadow intensity, and I'll pass number 3, and here is shadow softness is 1.5. And don't worry about the numbers here. Like once you start using it, you figure out what are the numbers that work best for you. I figure that this is really good enough for the robot. You see the shadow below with the softness and everything. This is all good, but still we cannot really interact with the robot. It feels like an image. I mean, if somebody shows me this and an image, I'll think it's image, right? Because I cannot do anything. So how we can enable actually interactivity here? For that, there is a property which is called camera orbits. Not camera control, not camera orbit, camera controls, sorry. That's a Boolean property that we can pass on the model viewer. And once we go there, now we have a 3D model that we can actually play with it. We can even zoom and zoom out.
And it's really smooth.
It's really smooth. It's very performant. I'm not sure how it goes through the live stream, but here on my screen, it's like just happens immediately, right? Because
looks good from here, and I'm pretty far away from you.
That's true. Yeah, so you see, with just a few lines of code, we managed to render a 3D model. We allowed actually for changing how it looks and what's the angle that we are viewing it. It's amazing. Let's get a little bit nerdy here, maybe, and try to look at what goes inside, right? So for the people who are curious of actually what is inside. So this is the model viewer web component. I will zoom in a bit. Maybe you're not seeing it. Something to this extent.
Yep.
So this is the model viewer web component here, right? And then when we go in it, we see there is a shadow root, and then there is some few diffs over here. But I want to drag you to something that's a little bit more interesting. So there is this diff, and then inside there are some slots which the model viewer allows actually us replacing the slot with something from outside the model viewer. But what is really here that happens is just a simple canvas, right? So the whole magic of this is plain canvas that renders the model, and when we rotate it, it recalculates what's the new position and just displays it. That's how it makes this feel of actually that you're looking at something 3D, but in fact, it's just a 2D image of the thing that is 3D. And as you can see here, we have WebGL Canvas. That's the 3GS already, how it renders it, but that's pretty much all the magic behind it, right? And then as there are a bunch of slots that the model viewer allows us to change, so we can replace, for example, the poster, AR button, and a lot of different things.
And that's basically to customize the viewer, so to speak.
Yeah, exactly. Cool. Should we try to get a little bit more nerdy maybe and look what goes inside the GLB file? Because we talked about GLB file,
because this is not much of a configurable product to me. If I'm going to buy the robot, I want it in different configuration, right?
Yeah, definitely. So let's see what we can do about it. First, I will start with exporting a little bit the GLB file. And for that, in VS Code that I'm using currently, there is an extension which is called GLTF tools, which allows exactly that, kind of exporting that GLB file, which is the binary file, right? And turning it into GLTF, which is the JSON representation of the binary file, which is in more human readable format. And then we can look at actually what goes in there. So I'm going to do that over here. I'll save it just somewhere on my screen. And the good part is that here we have also a preview. So I click over here, and you see now here we have the same model, same robot here in my screen.
And everything here is in JSON. That's the full model, or?
Yeah, that's what's the binary file kind of. This is just the JSON representation.
Yeah.
Yeah.
So I'm thinking like SVG for 3D, right? It's not the same format, but it's the same principle. It's a human readable format for manipulating and defining 3D objects. Yeah.
Yeah. And as you can see here on the sidebar, there are a bunch of images and everything that are put it into the binary file. But when they are extracted, we can just see these images, and some of them are like material maps and etc.
Yeah.
But let's take a look on some of the properties here. So I'll go over some of them. Let's grab here the scenes. So the scene property describes like actually what goes on the scene. And if you have like animation or a video, you may have different scenes. But in our case, we have just a single scene. And then you see that one scene contains one node. And think of it, I'm not sure, do you see well? And then this node is the shape. Think of it like one node is one shape. So here we have a shape of a robot.
Okay.
And over here, it's described actually what's the node. So this is node 0, as you can see here.
So
and the
it's
node
basically an array of nodes, and you index it from 0 is the first is the second, like we do in code, which makes a lot of sense.
Exactly. And then let's look at a little bit down further down. So we have here materials property. And this material property is array of materials. And there are a bunch of properties, but what is interesting here, for example, this first one material is called cyan. So this is the material that goes on top of the node. So think of it, the node is something without colors, without any kind of roughness, metallic roughness or anything, just like a bare shape. And then the materials are what goes on top of it. This now gives shininess, gives colors, light reflection. There are a lot of different properties, right? And that's what this material here describes. And then if I look at the next material here, we have a material which is called copper. And you can see there are different metallic roughness and texture and everything that describe this material. And then the last one is actually called gold. And then here below, we have a bunch of other properties, which I'm not looking at now. So why I'm saying this about the materials, right? Why it's important.
But to interrupt you, what you saw below there with the meshes, that's actually the 3D definition of it, isn't it? Or
yeah, different elements here, as you can see, with the properties that actually. The good part is we can use this tool to change different properties, and then that we will render, and then you can see actually what are your changes.
Yeah.
So you can definitely play with this.
Nice.
Yeah. So to get back to the materials, why I'm kind of mentioning that is because the model viewer has built-in support for material variants. And that's exactly where actually your board started with the product configurator, right? Because we have a single shape, but then we have different colors, because that's quite often the case, right? We have, for example, a shoe, and that shoe may be in a different, like a pair of shoes, right? And then the pair of shoes is the same, but then the colors are different. And then you'd like to be able to switch between different colors and see how they look. So the model viewer has that kind of already built in mind, because one of the ideas that the model viewer can be used is exactly for product configurators.
Nice.
So there is extension here that we need to add. It's actually added to the file, right? Which is called KHR material variants. And as you can see here, we have 3 variants, and these are just the name of the materials that I showed you below. So this cyan matches exactly this material and the name cyan. And this is enough, right? So the model viewer knows that this one shape can have 3 different materials. So once we have this knowledge, let's try to see how actually we can do a simple product configurator where we can change the materials. Should we?
No, let's stop here.
Because now it's getting excited. Come on.
Go for it.
Cool. Okay, so first I'll start with defining a model viewer reference, because that's how things work in the React world. But of course, if you're not using React model viewer element, you will do it in your own way. So here I'm creating the ref, and then I'm passing the ref to the model viewer. This is definitely the first step, so we can get access to the model viewer itself. Cool. The next thing here, I'm going to add a use effect, again, because that's how things are done in the React world. But if you're not using React, again, you need to find your way. And I will extract the model viewer reference into a simple variable, which is called model viewer. And what we want here, we want to listen for the load event. So when the model viewer is loaded, it will fire a callback function that will tell us the model is loaded, so we can work with it. So to do that, we have model viewer at event listener, this guy, and then we're going to say load. So when the model viewer is loaded, what we want to read these available variant materials. And to do that, there is a property on the model viewer which is called available variants. This guy. What should we do here? Maybe let's save this into a state. So we can use it. This is just array of strings, because what we the available variants are just the name of the variants. So they are string and they are array of strings. So here we say variants, and this will be set variants. Cool, and then we're gonna save this into our variants. Cool. Shall we try to see if this really works? Yes. How can we do that? Let's render like a few buttons on the screen that will be the different variants that are available. This is the first step. Okay, to do that, I will start with an ordered list. Try to be semantically correct. I will add a class name of action bar. This is just to position the buttons on top right corner of the screen. And then over here, let's iterate over the variants. And this will be a variant. And over here, to be semantically correct again, we need AY with the key of the variant. And here I will render just a button, and I will put here the variant name inside. Cool. Let's see now when I go back. Tara, you see here on my screen? Just
Nice.
Immediately. So these are exactly the variants that we saw earlier. So nothing happens when we click now because we are just reading them. So let's see how we can change the actual material. So here I want on-click event handover. On-click, like that. And then when the button is clicked, what we're going to do? So first we will check if the model viewer ref current exists, because otherwise a TypeScript is going to complain. And then we'll say model viewer current ref variant name. There is a property which is called variant name, and we'll just pass the variant. That's it. So like a single line of code that gets the variant and assigns it to the model. So here is the model, as you can see. So this is currently cyan. I click on copper, boom, it changes the color. Gold.
Nice. And as we started with, you can actually make these models yourself. And I have a feeling that you've tinkered with these colors yourself.
That's quite true.
So just because you can doesn't mean you should. No, just kidding. But
Developers, right?
Yeah.
Let the designer people decide colors and combinations.
That's not the point. This is really cool.
Yeah.
This is really cool.
Cool.
And of course, the materials here, you have a combination of all the different materials in this switch, right? So because here we have, I don't know, 5 different materials, 6, I didn't count. And each of them have the definition, and that's what you're just changing the reference in the GLB file. And to tweak these materials, that's where you can use Blender, right? Or similar tools to kind of get the right reflection, I guess transparency. You have the bump mapping, texture mapping, all of these things.
Yeah, reflection of the light, for example. See, this the cyan material here has some reflection, while the other materials, they don't have it. So they're definitely different materials. But what you mentioned, Bart, also, it's a very good point, right? Because with the model viewer, we don't want to download each of these models separately, like the whole file and everything, every time you click on a variant, because that also takes time, right? Yeah. And we don't want to preload it because the person may never click on it. But instead, we are just downloading the model once, and then internally using code, we are just replacing the material. And that's kind of the beauty of it, because it's fast, right? Doesn't take time to download images and to replace them or everything. It just happens right where you see it.
Yeah. And of course, I mean, if you go really, really crazy, I guess, with the resolution of both textures and models, I mean, but performance will probably be affected. But as we've seen, I mean, with really complicated models, even on just our laptop, it's really, really fast.
Yeah.
So
because again, we're using the GPU for rendering, and that's
exactly. So I I used to have an Intel-based MacBook Air, right? And trying this in there where it's not hardware accelerated, it's like 1 frame per 5 seconds. So the GPU is really, really the game changer here in our hardware.
Yeah, yeah, that's what allows actually, yeah, to do these things so performant.
Nice, nice.
Cool. Should we take
What's
a look?
next? Because, I'm changing colors is nice, but I want to figure out how I can add a saddle to my bike, right? Because it could be, so configuring a bike or a product with accessories could be a thing, but it could also be like, let's say furniture. You have let's take a shelf that you want to customize. What type of doors do you want? Where do you want them placed? To get that visualization, and maybe you want to have more of them placed in an environment to see,
Yeah.
do the 3 shelves configured like this fit in my living room? That's kind of, I would say, a big goal for me as a shopper if I'm using this kind of tool.
Yeah. Yeah, that's where actually kind of one additional things comes with the model viewer, which allows actually us to work with different attributes from the model. As you said, we may want to hide or show different attributes from the model depending of like if we're configuring it or if we want to see it in a combination with something else, for example.
Yeah.
Kind of to demo this today, I prepared a second GLB file here on my screen, which is called skills, where my idea here was that, okay, so now we see the robot in different variants, but what about if the robot has like different skills? For example, the robot may be good at cooking, and then we may want to actually show the robot as a chef, for example, right, with an apron and a chef hat. Or if the robot is, for example, Viking, right, and then we want to show the Viking horns and the fur and all that.
All that.
So let's take a look on actually what goes first in the file, and then we'll see how we can tweak it.
Yeah.
To do that, I will just replace it over here. I'll say skills GLB. So when I go back, you see that our robot now has like everything attached on it, right? This is a robot with the chef attributes, and then a robot with the Viking attributes all at the same time. So what we can do here, we can hide these different materials, and then we can allow the user, for example, to choose chef, and then we show the chef attributes, and if it's a Viking, the Viking attributes. So let's see how we can do that. First thing we need to do here, we need to tell the model viewer that we want to load this model eagerly. So loading is going to be set to eager. I'll tell you why in a second. And then the review, which is called review, will be manual. And the final step here is poster. So, and here I'll just poster webp, which is actually just the file that you get to see here in my public folder, poster webp. So what we do here, first we're telling the model viewer, show poster. So this is actually done quite often because the model viewer file could be a little bit bigger, right? So what we can do is that we can show an image of the first frame of the model, how it's going to look. So that's going to happen right away because the images are small, right? And then when the model is loaded, we can remove the image and then allow people to interact with the model. Yeah. So here we are telling the model viewer, show a poster, but don't reveal it. Wait for me, I will reveal it. This is a view menu. And loading eager says that even the model is not visible, go behind the scene and load it. Yeah. That's what we tell. So now if I go back here and I refresh, what you see here is just the image. You see I cannot interact because I'm not removing it.
Cool. Yeah. So this is like eager prefetching in Next.js, for example. It will load the pages and they're ready for you when you click.
Yeah.
It's not the same, but I have to say something.
Cool. So maybe next step from here, we can explore what goes inside the skills GLB file, because I think that's gonna make things a little bit easier to explain. So I will unpack again the skills GLB file, and you see here the preview is the same, is the robot with all kind of skills. And over here, what is different this time? So again, we have our materials as from before, nothing changes. But this time, our scene contains a bunch of nodes. And for example, if I delete, okay, let's take a look what are the nodes before deleting anything. So no, you see node 0 here is the robot. So this is the robot shape from before that we had. But then the next node 1 is a Viking head. And then node 2 is Viking fur. And this is the chef head and chef apron. So these are our nodes. So if I go over here and I remove, for example, 3 and 4, just like that, and I run this preview again, you see now that we are just seeing the Viking attributes. And if I put this back and I just delete these two, which were the Viking attributes, now it looks like a shape as a chef.
Yeah.
What is bad about it is that if you remove it, that means it's not going to be in the GLB file anymore. And then when you switch between these skills, you need to download it again. And we don't want to do that.
Because so you could kind of do the same by having all the different combinations in all or in different files and just loading them when you click, right? And that would be sluggish.
No. Yeah.
so you don't want to do that. And
imagine how many combinations.
Yeah, exactly. And what I was going to say with product configurators, because in like a sofa that we looked at, it could be hundreds of thousands or at least thousands per model. If you go to cars, which are, I mean, like a billion configuration options in at least some of the clients we have when you build car configurators, and it's exactly this, like just define the different dimensions that you can play with, and then turn it on off. You can change material, and of course also change positioning and move it around in the scene if you want to take it to that step.
Yeah, exactly.
It's really powerful.
That's where the power comes. And then one last thing I want to show here before we're going back to the code. So we saw the different nodes, like the chef apron, chef hat, Viking hat, Viking fur. And these are the nodes, the shapes, right? But then we have materials. And if you see here the materials, this time we have a little bit more. So we have the cyan, copper, and gold from before. These are the materials for the robot shape. And then we have a material for the Viking head. And then we have a material for the Viking fur, head, and chef apron. So all of these nodes, they have also materials. So what we want to do here, we want to kind of load the model behind the scene, hide these materials. How do we hide them? We make them transparent. We hide them, and then we allow the user to choose a skill, for example, chef, and then when we select that skill, we just show the materials which are for that skill. That's how we do everything, right? That's the whole magic. So let's see how we can do that by code. First, here I will start with a simple maps that I prepared, and I will explain now something that's just to simplify things. So here I have a simple map between the skill and the material name. So this universal chef and Viking could be anything. It doesn't matter. This is how I named these skills. And then these here are the material names that match that skill. And this is important that these skills, they actually match the material name in the GLB file. So this could be configured in your CMS system or in different place. I'm doing it here so actually people can see what I'm doing, right?
And this is also what you could then do if you set up a shape in Crystallize. You can have it dynamic. So you upload the GLB file and you just add the configuration dynamic to the product so that it's, editorial users can actually add new models and manipulate fabrics and things like this with full control.
Yeah. And then here I'll add another, if I remember the name, skill material. Skill array. So these are just the skills. I'll explain again. So I'm reading from the map. I'm reading just the skills, nothing really complicated. And then here I have a material name array, and these are just the material names. I will explain in a bit why, just to simplify things, right? Okay, and I don't need const twice. Cool. So what we want to hide materials. Let's add a function that hides materials. So this will take the model viewer element, which is a model viewer element. And what we want to do here, we want to iterate over the material names and hide all of them. So we're going to say material names for each, like that. Material name. So first we want to grab the material for that. We want to grab the material for this material name. That's the first task. So here we're going to do const material. And that will be model viewer model get material by name. So there is a built-in function that you pass a material name like that, and the model viewer will return you the actual material. So once we have the material, we need to do two things. First, we need to set the alpha mode. Why we need to set the alpha mode? Because think of it that if you want to make something transparent and you want completely to disappear from the screen, but at the same time, the default behavior for the model viewer, if something is transparent, you are still able to see it on the edges. For example, imagine you're looking through a glass, right? You want to see through the glass, but you want to see the actual glass because otherwise you don't know that it exists. So our case is a little bit different. We want to actually completely hide this this material. So that's why we set the alpha mode here to be masked, and the blend is the default. And then for the material, we need to change the color. How do we change the color? So on the material property, there is a property which is called PBR, which stands for physical based rendering metallic roughness. There is a property which is called set base color factor. So it may sound complicated, but once you know it exists, it's very easy to work. And then the base color factor accepts either a RGB string with the hashtag in front, or it accepts array of numbers which are fractions of 1, which represent the RGB and the A channels. So here I will say 1, 1, 1, 1, and then 0. 0 is the alpha channel, right? This is the last one. And I cannot save. What is that? Okay, now save. So this represents the alpha channel, the opacity. So we just make it invisible. So now this is how we hide the materials. We just iterate over the material names, which we know, set the alpha mode to mask, and then we make them transparent. So when I go into my use effect here on the onload, what I can do, I can say hide materials, and I can pass the model viewer here, like that. So the problem is now if I go back here, you see nothing really happens because I'm still seeing the actual poster. So now I need to remove the poster. Let's do that. So this is model viewer. It's called dismiss poster, this one. So let's see what's going to happen now. So I'll refresh. And this is our model. So what is annoying here, as you can see on the screen very much, right? The blink of all the materials. Why that happens? Because, in JavaScript, everything runs kind of in the loop. So we remove the items, we hide the items, and then immediately we dismiss the poster. So kind of it runs in the same event loop, and then we get to see that in the blinking of an eye, which is very annoying. What we can do, very old JavaScript trick here, we can do set timeout, right? And then what we're gonna set timeout for is just 0. So what we're gonna do in this case, the event loop, JavaScript event loop runs on the main thread, right? Then we hide the materials, and then we push removing the poster into the next event loop. So now when I refresh the screen, boom, nothing happens. So see, I loaded a very complicated 3D model that loads very fast because we are showing a poster, you get to see something. Then we load the model, now I can interact with it. Cool. Isn't this cool?
This is really cool. I was just thinking about the trick with the event loop.
Yeah, I kind of discovered that if somebody else discovers a different way to handle this, please let me know. I'm open to hear it. But that's what I figure is the problem. Cool. So what we want to do here next, we want to render these skills, and that's where I'm going to use these skills over here, array of skills, right? As a buttons on the screen, again, where the user can click and decide what you want to see. So what we're going to do, I'll just copy paste a little bit this guy. So in this time we will iterate over the skills, and this will be a skill, and this will be a skill. and this will be a skill, and this one will change. So if I go back, you see now we have the skills, universal, chef, and Viking. Nothing really happens. This thing still works on the top. Cool. So what we want to do here? First, let's grab the model viewer without reference, because that makes things very long and hard to work. So first we say, if the model viewer exists, this is mainly to make TypeScript happy, because we know that it's going to exist.
And TypeScript needs to be happy.
Yeah, always. So if there is a model viewer, that's what we're saying, let's hide it. Let's hide all the materials. Why is that needed? Because, for example, if you're viewing a chef, we want to hide the chef and show the Viking, for example. So nothing really happens. But what we want to do instead, we want to grab that skills material map of the current selected skill. And then for each material here, this is actually material name to be more precise. Material name. We want to show it. How do we show it? Again, we grab the material, which is a model viewer, model get material by name, and then we pass the material name. So once we have the material, we just want to change the PBR metallic roughness, set base color factor, and this time we do 1111, which is just changing the alpha channel, making it visible. So let's try now this. Okay, so this still works on the top, and I say I want to see a chef. Boom.
Nice.
How about Viking? Boom, it's there. Universal, it's without any skills.
Exactly.
So see now, as we said, imagine handling these combinations with images, like this combination in this angle, this angle, this angle, and then this with this and that. It's insane for something that you can just do it, as you saw, a few lines of code and 45 minutes of coding. And less.
And I think it really shines in the complex product or configurable product setting versus just having your product in 3D. That's nice, but then you get the mismatch between the real world and the model. But of course, you can place it in the real world, right? I mean, because you said something in the beginning. I'm just hoping that there's something you can show.
Okay, let's see how that's going to work. I'm also excited about it. Cool. In the beginning, we said that's, of course, it's nice to configure this, but when you actually can view it in your own context, your own home room or place where this is going to be used and stay or whatever, it really makes difference. So how we can enable AR or augmented reality with the model viewer? It's extremely easy. It's so easy that I couldn't even believe it the first time I was working with it. And over here, I prepared an AR folder with 3 different models: Copper Robot, Cyan Viking, Golden Chef, just different combinations. And the only thing that you need to actually do to enable the augmented reality is to pass a Boolean property to the model viewer, which is AR.
Yeah, exactly.
That's everything. You don't need to do anything else.
That's actually not hard at all.
Nope. I'm sure that even the designers can do it.
That's for you, Diderik.
Yeah. So over here, I prepared this one page with different QR codes. And what I will encourage you to do, grab your phone and scan one of these QR codes, kind of the one that you want to buy. Think of it. Scan the QR code, and then it will open on your phone in your browser. And then when you see the model there, right? At the bottom right corner, you see the AR prompt where you can click it, and then it will ask you to actually view it in AR. And because we're in a live stream now, and people may not have a phone with them, which I doubt, but still, what I will try to do here, I will scan one of them. Which one I should pick, Bort?
Do the Cave Guardian.
Cave Guardian. Okay, I like that guy. Cool. So I will open it here on my phone, and then I will stream from my phone to the computer so everybody can actually see how it looks in augmented reality.
And that's a stream in a stream for those that didn't get that.
Exactly. Okay, so give me here a sec. Also, actually, I'll give you a second here that you can try to scan a QR code and load the app until I figure out the whole streaming situation.
Yeah, and of course, take a screenshot if you wanna want to try at a later stage, or of course, the video will be available on YouTube, and you can always get back to it later. And I think this here is a good example of how you can have a configurable product, but you can also have pre-configured, let's say, staff favorites that that Vasil did here, like a landing page, and that could be a starting point also to, okay, this combination is good, this combination is good, but you do you, so you can configure exactly how you want your product to be. So, I really like that. I can also show an example for those that are interested in how you can use that. So if you have the, let's say, back to the boilerplate here where we started. So this is an example. Again, you can grab it on our website and play with it, but it allows you to configure a product. But maybe you also want to have some staff picks. So here's an example of kind of what Vasil showed with the robots here, where it's pre-configured variants of different products. So here you can have, I know that this combination looks good, and that could be a starting point to inspire you to configure your own product. But that's just another example here. If
if you show my screen, I'm already I had some internet problem here, but it's now solved. Do you see actually, or you don't see it?
I see a big black screen.
Maybe because that needs to be moved. So I'm not sure. I was just why? Okay. For whatever reason, it's using the other monitor. It's using the other monitor, but I don't have clue how to. Okay, I'll try to unplug. One simple trick to see if do you actually get to see it now?
Maybe you have to stop and reshare your screen, something like that.
Yeah, let's try that.
Because you're sharing a different window. This is exciting, right? You've probably already gotten this up and running on your phone. I know I have. But it's always nice to see how you can get it in real life.
Okay. So now, give me a second here.
Now I think you're sharing maybe.
Yeah.
Now I see your stream window. Yeah. And now I see that. That's perfect. You followed us debugging. That's the best part of everything, right? So
okay.
This is Vasil's living room.
So do you see it?
I see it, and it's and kind of this is this is what you started with. So this is really where you see the value of it. Yes, the materials here maybe aren't tuned for lifelike. You can of course do that also, but that's not necessarily the point. You see the combination of what parameters you have chosen, and you see the physical dimensions. And this is with I'm not sure if you have an iPhone. Yeah, it looks like you have an iPhone. And you can really just place it in a room. Think of placing a sofa or a shelf or even a car in your garage, right? A lot of value there. So I think that's where we end it today, Vasil. This is really interesting, and to be honest, we went nerdy. I mean, you went nerdy, but it's not super hard, right? It's not super advanced to code. Yes, it's super advanced technology that is underlying this with the GPUs and the libraries, etc. But for you as a developer, or if you want to hire a developer to do it for you, it's really accessible. We've been now a small hour here, and we've been doing a lot of jabbing, and we have a 3D model that you can view in AR and configure, right? So it's I think it's really cool. If you want to learn more or chat with Vasil and the other people in the team that know how this is working, you can join our Slack channel. We have a community Slack. And of course, we are doing several of these live streams, typically once a week. So if you watched, and there are people that watched all the way to them because you're hearing this, right? Do subscribe so we get a couple of more followers. And that's it for us. And see you in the next one.
Yep. Thanks. Bye.